Hi, welcome to another video from the Cooltech channel. We're trying to keep releasing a video every week, so if you like what we're doing and you want to support us, so please subscribe and like the video, and also press the notification icon to get updates on more video when we will release them. Now, have you always seen all the amazing setups for your PC environment with the RGB lighting on the walls? If you want to build one for your setup for a fraction of the cost of a Nanoleaf, which is pretty expensive, assuming you have a 3D printer, we will show you how to do one. In the next video, you will see all the needed parts and how to get all the parts together in this video. So let's get started. The parts that we will need, everything will be listed in the description below. The first one is the controller. We will use the NodeMCU ESP8266 controller. We will need RGB LED strip, which is W2182B, the 5 volts model, 60 LEDs per meter. We will need a few Servo Extension cables, power socket, 5 volts power adapter, and for your 3D printer you will need the white PLA, and of course soldering iron, which you should already have. So to begin, we will get to the Moodlite project homepage, which is Moodlite CO UK. Again, I will add all the links to the description below. And we will need to register to the site in order to get all the needed files. Now, if you like this project and you want support, you're more than welcome to donate to the site owner who built all this project for us to use. After you registered and log into the site, you will have this download section available for you. You need to log in, go into the download section. Here we will have two categories. One of them is the Moodlite design and the other one is the Moodlite software. The design is all the 3D files we need to print, and the software is all the controller related files. So let's go into design. We will use the latest release 2.0. Save the zip file into your computer. After you save it, let's go back to the software and download all the 3.0 release files. Again, save the zip file into your computer. Now let's go and start printing all the parts. I will unzip this version 2 file into this same folder. And now I need the STL files. Let's see what we have here. We have here 5 files, we need only 4. So let's start with the tile bottom file. Open your Cura slicer, which is the one which I use. You can use whatever slicer you feel more comfortable with. I will add a link to the Cura slicer in the description below. So let's drag the tile bottom to our Cura slicer. Let's see what we need to do. So let's flip it over to have the flat part of the tile on the build plate, like this. Now the settings for PLA are a 1.2 mm wall thickness, infill density 10%, 210 degrees for the hot end, 60 degrees for the build plate. And what more important is the support. Now this part have few channels in the bottom. We need to use support to able to print it, not everywhere, touching build plate. And that's it. Now if you're using SD card for your 3D printer, and slice the model and save to your SD card, but I use Octoprint server, so I just save the file to my computer and then upload it to the Octoprint server and print it. Now let's print the model. So now that we have the tile bottom part printed, should look like this, nice and shiny if you have a bed level and you're printing on a glass surface. Now we need just to remove the supports. They should come off pretty easy, like this, and this is more tricky. No, came out pretty easy. Should look like this. Now let's go back to the top part. Just remove the last part firmware Cura and drag the tile top file now. All the setting can remain the same. We don't have here any need for supports, so supports won't be printed. Slice it, and again, if you're using SD card, print from your SD card. I just upload it to the Octoprint and print it. So now that we have the part printed, again, if you're using glass surface, should be nice and shiny. This part is important because this is the part it will be facing you, so it must look good. Okay, so now we have two more parts to print. We have two more parts which are called the power bottom and power top. Power button, again import into Cura, all okay, same settings, no need to change everything. Slice, save into your computer SD card, and print it. So now that we printed the power button part, should look like this. Let's print the last part, which is the power up. Again, remove the parts from your Cura, and we need the power top STL. Again, everything should be as it left before. Slice it. Save to your SD card or computer. So after printing, the part should look like this. This is just the cover for the power tile. Okay, now let's start assembling everything together. So I will show you how to assemble one tile. This is the bottom part. This is where we get everything assembled, but you will need to repeat it as much as you will have If you have 5 tiles, you need to do it 5 times. If you have more, then more. I will show you just one. So this is the servo cables. You have the female side and the male side. You have the RGB strip. We will need 3 LEDs for each tile. Let's start by cutting them on the line. Try to be precise so we'll have enough pads to solder. 1, 2, and 3. Okay. On each one of the LEDs, you have a little arrow which shows you the direction of the signal, and also the input pins are labeled as D-in, like data in, and the output is DO, like data output. So go in like this, go out. The order of the signal should be from the male servo connector to the data in on the LED, then data out to the second LED, to data in, then data out to the last LED, data in to data out, and then to the female side of the cable. Now let's start with the first LED. Flip the tile over and note that you have this channel and this hole through. Okay, so this should contain the male side of the servo. Should go in like this. Snug the cable into the channel. And push it inside like this. You see? It should stick like this. And the cable should be all into the channel. Now you can hot glue it all inside, or just leave it like this if you wanna do something in the future. Now what we need to do is to measure the cable length until the first LED. The LED should be held in place here, so we will need about this much of a cable. So now I'm gonna cut it. Okay, let's see how much cable we need for the second LED. The second LED should be in the next corner, like this. So I will need about this much of a cable. Cut it. Okay, this should go here. And the third cable I will have to cut another servo cable. And for the third LED, again measure about this much. And the last LED should go in here. Now here you should flip the tile over and know that you have 2 places to put the female side of the servo. This in order, if you want to arrange the tile differently, you should be able to connect the next tile from here or from here. So you have 2 channels to choose from, but the lane should be the same. Just insert the female side of the servo inside, snag the cable through the hole, and it should be enough to reach the third LED. Should be okay like this. Okay, Now that we have all the cables, let's take everything out, including the LEDs, and start soldering. Let's see. This is the male side. And the female side. Put the tile aside so it won't interrupt us. Okay, now let's begin. Like we said, we have the male side. Go into the first LED. Okay? So now let's start by soldering this all together. I will start with the first LED, and like we said, the male side of the cable. The red one should go into the 5V pin on the LED. The white one is the data, the in, and the black one is the ground. Should look like this. Okay, now let's go and continue soldering the second LED. Now the second LED, again, the output from the first one is the input on the second one. Now for the third LED output, I have the female connector. Now it should look like this. Like we said, the male connector, first LED input output, second LED input output, third LED input output to the female side of the cable. Now let's assemble it into the tile, starting with the first LED. This is the hole, okay? So just push it inside, remove the glue tape from behind the LED, insert it into its place, give it a gentle push. Now let's insert the cable. Like this, and pull the remaining cable out. Like this. Okay, now let's continue. Second LED, get the sticky tape out, and okay, now the third LED, Okay, and the connector should go into the hole to the other side. And here, depending on how you arrange your tiles, you can choose the location. See? Okay. Should be like this. We have the first LED, second, and the third, and the opposite side. Everything tucked away. Now, for closing the tile, take the upper part, just push it into place. Should look like this. Now that we finished with the tile, let's go for the power part. This is the part. The controller should sit on its place. Okay, here the power comes in, and here the connector for the tile, it should be connected like this. You can see this connector. This is the female connector of the controller, should be connected like this. Now we're gonna solder everything into place. For the cables to the controller, you should have the female connector with the data cable, the plus and the minus, positive and negative 5 volts, and another cable which goes into the power. I didn't get my power connector in time, so sorry. I'm gonna just connect to it by these two cables until my connector will get in the mail. So now let's start soldering the connector, the controller, sorry. The power cables go from here, and the female side should go into this channel, like this. Now, for the controller, I will add the schematic for it. So the positive from the power connector should go into the first pin. This is the V-in. The second is the ground. And the data, which is the white cable from the servo female, should go into D6 leg. So, like we said, the first one is the V-in. Should go like this. The ground is the second pin. And the signal should go to D6 pin of the controller. Let's solder it together. And for the D6 pin, should look like this. First V-in, ground, D6. And the servo connector, like this. And then the cover. Now you can use hot glue or screws to keep the controller into its place, and close the cover like this. And the tile, once you hang it on the wall, should go into the connector, like this. Now, for mounting the tiles on the wall, you have the holes on each corner of the tile. You can use screws or whatever nails to your wall, depending on the type of your wall. I just like to use double-sided tape, so it will be much easier to hang it on the wall. Now that we finished assembling all the parts, now we need to burn the software into the controller. So in order to do this, we will follow this link with the full build log. Here on this page you need to scroll a little bit down. Actually a lot down. And here you can find this link which goes to the wiki of the Moodlite project, which called Preparing the Arduino IDE. Follow this link. Now we need to prepare a few things before we can upload our software into the controller. First of all, we need the Arduino IDE from the link which is here. Follow the link. As I'm using Windows 10, I just follow the first link, which is Windows installer for Windows 7 and up. I just need to download it. Save. And install it into your PC. Now that the setup is finished, let's go to the next step. Go back to the build diary. And again we will follow the wiki page. Now we need to follow the steps. So we will get into the Arduino software which we installed, and we go to File, Preferences, and under Additional Board Manager URLs we will copy and paste this URL. Exactly as it says. Okay. We don't need additional ones, so just press OK. Now we go to the next step. We go to Tools, Board Manager, like it says, Tools, Board. Let me just move it a little bit. Tools, Board, Board Manager. And let's see what we need to do here. Like it says, and we need to type ESP8266 into the search. ESP8266, and we need to install this add-on. Installing. Let it finish. Installation complete. Let's see what is the next step. Now we need to install the required libraries. So we go to General, Sketch, Include Library, and choose Manage Libraries. We'll close this window. Sketch, Include Library, and to the Manage Libraries option. Next, we will need to install a few libraries. We need a ESP Async web server, so we will download the library zip file. First one. Then ESP Async TCP. Save this one as well. Okay. Now to add the zip libraries, we actually need to close this window. This will come later. Go to Sketch, Include Library, and we will use the Add Zip Library option. Open this one and just go to the folder which saved the zip libraries, which is this and this one. First one is the web server. and the second one is the TCP. Okay, now let's continue to the time zone library. Include library, manage libraries, and we will search for the time zone. Just type time zones into the search bar and scroll a little bit down. This is the one we need. Install it. Install all. Okay, it's done. Let's see what is the next step. We need the timer library. Again, this is a zip file. Save it. The time library. And again, as we did before, this is the zip library, so we'll go to Sketch, include library, and Sketch, include library, and add zip library option. Again, we have the timer. We have two, timer and time. So first one is timer, and another one is the time. Time. Okay. Now we need the pub sub client, which is library which we need to search. So we go to manage libraries and search for it. This is the one which we need. Install. Done. Let's see what is the next package. Fast LED. Fast LED library. Install. So we're done with the libraries. Just close this window. Let's see what is the next step. We need to adding the SPI FFS support. So we need to download the tool. Follow the link. Save it again. So after we download the zip file, we just open it. And here we will see this folder, which is the ESP8266FS. We need to copy this folder into the program files Arduino tools folder. So just drag it. Continue. And we will have now this structure, tools ESP8266FS tool, and this file jar. Let's see. Tool and this file jar. Okay. Let's minimize it, go back to Arduino software, and we need to restart it. Close it. Start it again. And we should have this option under the tools. Let's see, tools, ESP sketch data upload. Okay, so we finished this step. Let's see if we have the right settings. We should have all these options available under the tools menu. ESP sketch data upload, board we should be able to select NodeMCU 1.0. Let's see. Okay, looks like we have everything set up. Let's continue to the next step. You should go to exactly the same page and scroll even further to the step which is called first setup of Moodlite. Let's go into this page. So now we need to upload the sketch into the NodeMCU controller. In the first steps, we download this zip file with all the needed software. So now we need to follow the Moodlite Arduino Moodlite link. Here we will have a file which is called moodlite.ino. Double click it, it should open with the Arduino editor. It should look like this. Now what we need to find is this section which is called basic settings. This is what we have. Let's see what we need to change. We need to make sure that the static IP is set to false. Static IP is set to false. Now we will connect our board and we need to find the COM port of the board. In order to find the correct COM port, you need to plug your board into your computer with micro USB cable, and you need to go to your device manager. If your board doesn't appear here after the ports COM and LTP port, you need to install the correct driver for it. You need to follow the link which I will post in the description, which is called the CP USB to UART bridge VCP drivers. Just download the driver for your operating system. Save it to your computer. Unzip. And run the installer for your operating system. Mine is 64-bit. Now that you finished installing it, go back to your device manager and unplug and plug the board back. Now it should be recognized here. And I also have the COM port number, which is COM7. Now we will go back to the Arduino software, and we need to make sure to select the correct port. We'll go to Tools, make sure to select the correct board, which is the NodeMCU 1.0. Let it finish loading. And now, under the port option, let's select port COM7. After this, we need to click the Upload button. Upload. Now you see that it's compiling. Let it finish. After finish compiling the code, you might get some error messages. Just disregard them. Now, after making sure that all the settings like COM port, the board model, flash size, all correct, what we need to do now is the sketch data upload. Pressing this, we will get the SP tool not found error. This is something I just found out, that you need to update the version of your SP tool which we downloaded. I will post a link in the description for the newer version of the ESP tool. We will just download it from the link. This is the newer version and this is the older version which we installed. We need this 0.40 zip file. Just open it and go to your Arduino folder, tools, delete the old one. We need to first close the Arduino software, it will not let us delete it. Delete the old folder and copy the new version. Continue. Let's see if this works out. Again, start the Arduino. Let's see all the settings. COM port 7. All is correct. Let's try it again. We get another error. So guys, we have another problem. Apparently the ESP tool, which is the latest version 2.7.4, is incompatible with all the old files which this project was built for. So what we need to do is to uninstall the previous version of this tool by going to, let me close it, Tools, Board Manager, and searching for the ESP8266. You will see that it have installed in your case. Just uninstall it. Afterwards, we need to install version 2.52. Just install it. Installation is complete. Close the board manager. Now actually, after we select the NodeMCU 1.0 version, all our settings will look exactly like it says here. Let's see. We have the flash size. We need to select 1 megabyte. Tool. COM port, in our case, is 7. And all the rest should be the same. Now I can upload the sketch data. Press it. Let's see. It's connecting to the board and flashing the memory. Once it says this SPIFS image is uploaded, it means that it's done. You can close the Arduino software. And now unplug your board from the USB port, plug it again, and now we can go to your phone to continue the settings. So after plugging the board back into the USB port to power it, we should go on our phone to the Wi-Fi settings and we should look for the Moodlite access point. It might take time to find it, just be patient. Here it should appear. Moodlite, the password is Moodlite with capital M. Join. Wait a minute or two, it might take time also. After joining the Moodlite Wi-Fi access point, go back to your browser and enter the following address: 192.168.100.250. It might take a while to load for your first time. Mine is a little bit faster. Here we have all the Moodlite settings, which we need to do first time setting. which is here in the settings menu. You need to input the number of LEDs per corner. So we have 3 LEDs in each tile, so we leave it like this. And we have 6 tiles in my case, so it's total of 18 LEDs. All the others not as important. Save and restart the server. After restarting the servers, you could go into the LEDs tab, and here we need to reload because the server is restarted. Here you can change all the settings. You can change the effects. I like the lava effect and also the pattern. You have a lot of them, just go ahead and play, see what fits you. I like the BPM. Okay. There is a lot of settings here. Just go ahead and play with it. You can also set the time of the day on which it will start and then power off. You can set the brightness of the LEDs, the speed of the color transition, and all the rest. Just save as default. And now you can unplug the controller from your USB cable and power it by the power adapter. Thank you for watching this tutorial. I hope you enjoyed this video. If you did, press the like button, subscribe to support us, and also press the notification icon to get notified on future videos. Also, let us know what you think in the comment section. Bye and see you next video.